It's a cool spring morning when a young girl emerges from her house, hand in hand with her grandmother. Burdened by heavy bags, the grandmother leads her past the other houses of the village. Grandmother didn't tell her where they were going, but soon the girl smells the damp earth and hears the running water of the stream that is starting to swell with winter melt. She knows now that they are going to the fields. Her parents have spent the last few days tilling the cold, rich soil and preparing the field for planting. At the field's edge, the grandmother sets down the bags and opens one up and beckons the girl to look inside. The girl peers in at the tiny seeds, inhaling their fragrant aroma. Her grandmother smiles and reaches inside and instructs the girl to open her hand, and she places several seeds into her palm. As the girl cradles the seeds in her palm, her grandmother tells her that these seeds are their past and their future. She tells her of an older village, far away and long gone, where her own grandmother took her to the old fields to plant these same seeds and taught her how to tend the shoots and nurture the crops, how to harvest the seeds and cook them, and how to save the best seeds for the following year. The precious seeds came from grandmother's old home, and now she tells the little girl in a slow, affectionate voice that one day, when she has a granddaughter of her own, she'll plant the same seeds in a new place with a new family. This sets the scene for our topic today, the Eastern Agricultural Complex. Now, when you think of crops in Eastern North America, you probably think of corn, or as we call it over here on this channel, maize. Some of you might even call to mind the three sisters, maize, beans, and squash, and how they formed the backbone of Eastern agriculture. But it wasn't always like this. As important as maize was to Eastern woodland agriculture, maize was late to the party, and it wasn't always the staple crop we think of now. Today, we are going to steal the limelight from maize to talk about the crops that came before it in the eastern United States. We normally don't think of this region as a hub of crop domestication like we do with places like Mexico, Mesopotamia, and China, but thousands of years ago, people here domesticated many different plants and cultivated them for centuries. Scholars refer to this group of plants as the Eastern Agricultural Complex, and these forgotten plants helped propel societies in Eastern North America, from which cultures like the Adena, Hopewell, Fort Ancient, and Mississippian cultures emerged. They were an important feature in the diets and lifestyle of many people in North America. Sadly, in the present day, almost all these crops are nearly forgotten, abandoned long ago with ancient ways of life. In this episode, let's turn our attention to the Eastern Agricultural Complex to discover how these plants were domesticated and how they transformed the cultures that cultivated them. This episode is brought to you by you, my patrons over on Patreon. They selected this topic earlier this year, and I must say that I was pleasantly surprised by this choice. If you'd like to vote on future topics, get early episode access, and keep the videos sponsor free, the link will be in the description. Thank you so much, wonderful patrons, for keeping this channel going. Couldn't do it without you. Also, want to say that I got a lot of help from Nate Fossane. He knows way more about this than me, and his guidance made a huge difference. He's got his own channel that I always recommend to our viewers. Go check it out. And now, back to the show. Let's start with a quick caveat about where today's information comes from. We only know of the Eastern Agricultural Complex from archaeology. Until the 20th century, scholars believed that there was no agriculture in the eastern United States before the arrival of maize. As it turns out, the introduction of the three sisters of maize, beans, and squash would change agriculture in eastern North America forever, and this is the agricultural model that greeted settlers when they first arrived in eastern North America. If the crops of the Eastern Agricultural Complex were still being cultivated, most appear to have escaped the notice of colonial accounts and ethnographers, or perhaps they were noticed, but those accounts just haven't survived. With two exceptions that we'll discuss soon, no modern indigenous groups continue to cultivate these plants to my knowledge. That said, if anyone knows otherwise, let me know in the comments. I'd love to hear about it. Thankfully, archaeologists have gotten good at detecting the remains of these plants by using flotation recovery. This is when objects like seeds and other burned plant remains are separated from sediment using water. And this technique revolutionized paleoethnobotanical studies in the mid 20th century because it allowed archaeologists to find remains of delicate plant material that otherwise couldn't be recovered any other way in useful quantities. You'll see this technique mentioned if you read about this in archaeological literature. If you're wondering how archaeologists know that these are domesticated crop seeds and not wild seeds, it's because the seeds that are recovered have certain characteristics. They have larger seed sizes, thinner seed coats, and in the case of squash, thicker rinds. And these are traits that archaeologists can see developing through time. Just keep in mind that almost all of what we discuss about the Eastern agricultural complex in this episode is based on archaeological work. With that out of the way, we need to establish where and when we are in order to discuss the Eastern Agricultural Complex. Going forward, I'm going to abbreviate Eastern Agricultural Complex to the EAC. Please don't confuse this with the East Australian Current from Finding Nemo, that's for another episode and another channel. For our story today, we are going to focus on this region of the mid-Mississippi, Tennessee, and Ohio river valleys. This area doesn't have a ready geographical term, so I wasn't sure what to call this area. The lower Midwest, the upper South, the Middle East. Those are all very wanting terms in my humble opinion, so for this episode, I'm going to refer to this as the EAC corridor. This is a term that I made up, so don't drop the term on some poor unsuspecting archaeologist or paleobotanist. You will probably get greeted with blank stares. It was either that or acronyming the states into a MAKETO. So yeah, we're just going to go with the EAC corridor. The earliest signs of domesticated crops in this area go back to between 5,000 and 3,400 years ago, during the late Archaic, and it's worth taking a moment to survey the Archaic period in eastern North America. This really deserves its own episode, but a brief summary is going to have to do here for today. The Archaic period in the eastern US spans from 8,000 BCE to 1,000 BCE, with the late period specifically covering 3,000 BCE to 1,000 BCE. The Archaic period is characterized by sparse mobile hunter-gatherer populations moving throughout eastern North America and seasonally exploiting various resources. Now, don't get the idea that archaic people were a bunch of simpletons going around living hand to mouth. They were deceptively complex and savvy people. To the south, these were people who built very impressive mound complexes like Watson Brake, Poverty Point, and the LSU campus mounds. We also know from archaeology that exotic materials like copper, galena, and soapstone were being exchanged during this time across very long distances, so these were pretty vibrant and industrious people we're talking about. Over the course of the Archaic period, these populations became better and better adapted to different environments, and we see these populations becoming increasingly local and wandering and moving around in smaller areas. By the late Archaic period, many of these populations were taking on more and more sedentary characteristics and staying at sites for longer periods of time. One thing that is worth bringing up is that there were also important environmental changes afoot during the Archaic period as well. Climatic studies suggest that during the Middle Holocene, many river valleys were still stabilizing and were very prone to bad erosion and flooding, which limited the ability of these people to settle in those areas long term. These floods may have erased some early and middle Archaic sites by scrubbing certain landscapes down to bedrock, just like the floods from Hurricane Helene did to western North Carolina in 2024. By roughly 4000 BCE, those valleys had stabilized, which resulted in meandering river valleys, as well as the formation of backwater swamps and oxbow lakes, which in turn promoted an abundance of plant and animal resources in the floodplains. For a good picture of this activity in the corridor, let's take a look at the Coster site in western Illinois. This site is located just off the floodplains of the Illinois River, a very fertile and productive area. The Coster site is really fascinating because it shows not one, not two, but 14 occupation levels over a 7,000-year period. Although the nearby town of Eldred, Illinois is a pretty sleepy town today, this was apparently a great spot back in the day, and it tells an interesting story. The earliest levels date back to 8500 BCE, but there's a much more substantial settlement during the Middle Archaic period around 5600 BCE. Those Middle Archaic layers show that people were living in pole and branch houses for long periods of the year and took advantage of fish, waterfowl, and edible grasses. The inhabitants were leaving larger and larger footprints as they committed to the area. 2,000 years later, between 3900 and 2800 BCE, permanent huts appear in the archaeological record at Coster. They were still living off of freshwater fish, waterfowl, and several types of edible grasses, but had reached the point where they could survive year round, no doubt aided by an intimate knowledge of the local environment and its resources. A look at the rest of the corridor shows a lot of consistency in subsistence patterns that we should note. First, many late archaic groups were settling in riverine environments, which were very productive areas. Faunal remains can show us that these people were subsisting off of game such as deer, turkeys, rabbits, and squirrels, and various types of fish, snails, and shellfish. They also made use of acorns, hickory nuts, and black walnut, and the remains of these show up all the time in late archaic sites in the corridor. Seeds from fruits like persimmons, hackberry, frost grapes, and plums also show up in the archaeological record, but in smaller numbers, possibly due to differences in preservation. There's a good chance that these late archaic populations were taking steps to modify the land in an effort to increase its productivity by creating stands of useful nut and fruit bearing trees and plants and removing competitors. Charcoal analyses have shown that burns were occurring more frequently, and this was likely being done to manipulate forests and to keep useful prairie habitats open. These people were living in managed environments, not wilderness, and these environments maximized very productive edge environments. Technology between these groups is also very similar as well. With one exception in Missouri, none of these people used pottery, although it would become prevalent during the subsequent Woodland Period. It's against this background that we see the EAC emerge. Now, when I say Eastern Agricultural Complex, what plants am I even talking about? Let's list them out here and give some brief descriptions of each plant. We have 7 crops total, but I'm going to break these plants up into 2 groups. First, we're going to discuss the plants where the evidence for domestication is really strong, followed by the plants where the traits of domestication are weaker, but we still know we're being heavily cultivated and consumed. Most of these domesticated plant varieties are extinct. Only their wild relatives survive, and it's worth noting that a lot of these plants today are considered weeds. I like to imagine them like jilted lovers who have been harboring a lot of resentment ever since they were kicked out of the garden, and have been stalking humanity ever since. In practical terms, this often means that these plants can be aggressive and resilient, which, as we'll see later, may have played a role in their domestication. First up is the most familiar crop of the EAC, one that is still cultivated today, the sunflower. I don't think the lovely sunflower needs much introduction here. It's a very tall annual forb that produces lots of delicious and oily seeds. It's very common across North America and can be found all across the United States and Mexico, although its original native range is somewhat disputed since it can thrive in different habitats. Interestingly enough, recent studies have shown that sunflowers appear to have been domesticated twice in 2 different places in the Americas, once in eastern North America and once in Mexico. We're going to ignore the Mexican domestication event in this video since it doesn't have any bearing on the EAC. The earliest evidence for sunflower domestication dates to about 2800 BCE. Next up, we have another American classic that I'm sure you're well acquainted with, squash. Like sunflowers, these are still cultivated today. Now, when you think of squash, you probably think of something like this, and that's not really what we're talking about. Those thick, fleshy gourds and squashes are more recent. At that time in eastern North America, the squashes had much thinner walls and were cultivated primarily for their seeds rather than the pulp. A single squash plant of this variety can produce up to 5,000 seeds. Nothing to sneeze at there. Wild squashes today are often found in floodplains, especially in disturbed environments. Of all the EAC crops, squash cultivation goes back the farthest in the eastern US, with early dates at 3000 BCE. Next, we got sumpweed, which often goes by the name marsh elder. This lovely and occasionally noxious plant is native to the central United States, particularly in the Mississippi Basin. As the name suggests, these little plants like disturbed, damp spots in floodplains. Sumpweed is considered a weed today, but it produces edible oily seeds, kind of like sunflower seeds. In fact, sumpweed is actually a close relative of the sunflower, although it never gets as large and doesn't have those bright floral characteristics. The earliest domesticated sumpweed remains date to just after 2400 BCE. And now we have goosefoot. If you're a wild food enthusiast, you may know it as lamb's quarters. I have no clue how it got those names. Nothing about this plant conjures images of goose feet or sides of lamb, but I digress. Goosefoot may sound unfamiliar to most of you, but I bet that you're very familiar with its close relative, because goosefoot is actually related to quinoa, which is a much better known crop that is still grown and consumed today, particularly in South America. They both belong to the same genus, and that should give you a good basis of comparison. Like quinoa, it also produces large numbers of starchy and protein rich seeds, but it can also be eaten as a fresh green and may have been in the past. Goosefoot is a plant with some impressive range, growing all the way from Canada to southern Mexico, where it thrives in flood prone environments. The earliest dates for domesticated goosefoot go back to about 1800 BCE. Next, we have the newest member of the band, erect knotweed. This is actually a relative of buckwheat, which my botanically minded viewers will point out in the comments is not actually a wheat or a grass. Although knotweed was known to be an EAC crop for decades, the first fully domesticated variety of this plant was not discovered until 2017. And fun fact, the scientific name for this domesticated variety is named after Patty Jo Watson, the mother of modern cave archaeology, whom we will meet again later in this episode. Like sumpweed, erect knotweed prefers disturbed low and wet areas. I hope that you're noticing a pattern here with these habitats and picking up on my cryptic foreshadowing. By the way, when I say disturbed areas, that could be an area disturbed by natural forces, like floods or by grazing animals or even humans. In fact, recent experiments have shown that in eastern prairies where bison have been reintroduced, their grazing and wallowing creates habitats that several EAC crops can thrive in. But back to knotweed. It produces edible starchy seeds from akens. It can be found in the northeastern US and the eastern Midwest. The earliest evidence for knotweed cultivation dates back to 1500 BCE, but the domesticated varieties don't appear until about 1 CE. The next two plants on here don't show the same degree of domestication as the others. However, we know that they were still being widely cultivated by these people because their seeds have been found way outside their natural range, so they were clearly part of the complex. If the EAC were a band, these two would probably be the backup musicians of the group, always present and contributing, but largely unsung by fans and critics. First, there's maygrass. This grass is native to the southern United States and thrives in wet, marshy environments. That's notable because it's not native to the EAC corridor, so its cultivation there was a very deliberate choice. As you can see, it produces many seeds on its stalk that can be easily harvested and consumed. Lastly, the seventh and final plant of the EAC is little barley. This is another native grass that can be found in most of the US and southern Canada. Little barley is distantly related to domesticated barley from the Old World, but its closest relatives are foxtail barley and meadow barley. Like other grasses, this produces several seeds and spikelets. These might seem like odd plants to cultivate, but they have the advantage of being able to be harvested in the spring when other food might be scarce. The earliest evidence of cultivation for both of these plants currently sits at about 1800 BCE. I do want to give a special mention to one plant that didn't make it into the EAC, giant ragweed. If we continue that band metaphor from earlier, this is the fifth beetle. Eighth beetle, basically the Pete Best of the group. Another aggressive, weedy monstrosity that loves damp areas, seeds from this plant are found alongside other EAC crops within a specific time frame from 2000 to 500 BCE, right when many of those other plants were undergoing domestication. To date, no examples of domesticated ragweed seeds have been found. The failure of giant ragweed to launch, I think, is very instructive and shows how people may have been experimenting with additional plants, but over time focused their attention and garden space on more productive or efficient plants. So that's our cast of crops for today, the 7 plants of the Eastern Agricultural Complex. Let's turn our attention to how these were domesticated. As I mentioned earlier, remains of the earliest EAC crops appear in archaeological sites dating back to the late Archaic, and they begin to pop up at a number of sites across the corridor. Sites like Marble Bluff in Arkansas, Phillips Spring in Missouri, Napoleon Hollow in Riverton in Illinois, the Hayes site in Tennessee, and the wonderfully named Cloud Splitter Rock Shelter in eastern Kentucky all have remains of EAC crops that date back to the late Archaic. What's interesting about these sites is that they can be categorized into two groups: riverine sites and upland rock shelters, though in both cases, these rock shelters are located close to small rivers. Rock shelters are phenomenal sites for archaeology because their dry environments are great at preserving organic material, such as seed caches. Even though they can tell us a lot about the material and food culture of a people, we're not going to focus on them right now. We're going to hone in on the river sites because these are likely the types of areas that domestication occurred. Remember what I said about a lot of those EAC plants? They thrive in disturbed habitats, and floodplains and river bottoms are a great source of such habitats. Late archaic people, being observant and curious as ever, probably noticed this behavior and tapped into it. They would have had seeds that they could have used to experiment in growing the plant in different conditions, such as giving them more space, weeding out competitors, and making sure that they had access to as much sun as possible. And how do these plants respond to those lovely garden conditions? Luckily for us, several archaeologists and botanists have taken a very keen interest in these plants and their domestication. And for the past decade, there's been some really interesting experiments done with these plants to see how they respond to growing in a garden. As it turns out, many EAC plants love being spoiled, and they behave very differently in a garden setting, and that's partly because of plasticity. Plasticity is what allows plants to assume different forms depending on the local environment. It basically gives the plants the ability to adapt to different conditions. A plant with plasticity might grow as a shrub under certain conditions and might grow as a vine under different conditions. You can also think of the difference between a tree in the middle of a forest growing straight up and a tree in the middle of a field spreading out. In the same way that we might play things safe in risky conditions and go for broke in good conditions, plants can have similar responses. As it turns out, experiments with EAC plants have shown that they have high plasticity as well. As an example, let's take a look at erect knotweed. If you were to find knotweed in the wild, it would look like an unimpressive herb competing with many different plants. But that same plant, grown in a garden, instead grows into a bona fide shrub with branches spreading out everywhere. Let's look at sumpweed. In the wild, this plant reaches a height of about 4 feet, maybe 6 feet under perfect conditions. Well, in a garden, this unassuming little annual goes on the warpath, and it can reach heights of 9 feet after a few years. I mean, look at this. These look like totally different plants. Experiments have shown that over successive generations, these varied and plastic responses become locked so that the plant's descendants begin growing a specific way, producing specific traits and features. As an example, a wild plant might create thick seed coats meant to survive the digestive system of an animal so that it can be dispersed in dung. But in an environment where the seeds are being intentionally planted and dispersed by humans, those selective pressures get relaxed. I'm sure this wasn't lost on those archaic gardeners, and I'm willing to bet that it really stoked their imaginations. It probably didn't take long for them to start experimenting with different seeds and strains. Judging from storage pits and other features at most late archaic sites, it's likely that these early gardens were communal efforts where the fruits of labor were shared. Thus, there was probably a lot of input going into these efforts. Heck, when we consider the wide geographic range that the earliest domesticated seeds are found in, we can conclude that this wasn't something happening in one little river valley, but rather something that was being developed across an entire cultural zone. You'll remember that even though these populations were dispersed, they still kept in touch and congregated in larger groups occasionally, and exchanged goods and ideas, so these crops began to take root across the EAC corridor. Another interesting aspect of the domestication of these plants is the diversity of it. Studies of ancient sunflower genomes in the Ozarks have shown that multiple but distinct types of sunflower strains were grown by communities. Similar differences have been observed in recovered knotweed and goosefoot in the EAC corridor. Clearly, these people weren't honing in on one type of domesticated plant, but encouraged many varieties. One thing that I hope that this drives home is that agriculture was not discovered or figured out. In some discussions about the development of agriculture all over the world, it's sometimes implied that hunter-gatherers didn't know how to plant seeds and harvest, and that's nonsense. These people were smart and resourceful. They would have understood their environment well, probably much better than you and I do, and they would have been perfectly aware that plants grow from seeds planted into the ground. These people didn't discover agriculture, they employed it. Now, that little rant aside, don't get the idea that people dropped everything that they were doing and just started farming intensively full time. It's not that simple. These people were still getting a lot of calories from hunting, fishing, and foraging. Those nuts that I mentioned earlier, like hickory nuts and black walnuts, still show up in large numbers at these archaic sites, along with game like deer. Those crops simply provided an additional avenue of nutrients and calories. But why were late archaic people taking the time and effort to domesticate and cultivate these different plants? It's often assumed that agriculture is the response of people facing increased competition for resources in an area that's reached its carrying capacity. This isn't unique to the eastern woodlands. You'll find similar arguments for the origins of agriculture elsewhere in the world. That is certainly possible in the EAC corridor, but Bruce Smith, in his oft cited 2011 work, The Cultural Context of Plant Domestication in Eastern North America, argues that those models don't really fit here. While he acknowledges that populations were increasing during the late Archaic, he points out that many resource rich river valleys and streams lacked significant human settlement during this time, and that subsistence patterns remained very similar for many centuries. If the EAC corridor was really getting overpopulated and strapped for resources, we shouldn't expect this to be the case. If Smith is correct and this is indeed what was happening, it would make the adoption of agriculture in the eastern US a very interesting example of domestication compared to what we see elsewhere in the world. Okay, at this point, it's the end of the late Archaic, and the EAC has spread through the corridor. People are growing a new host of domesticated crops in North America. Now we need to ask, what were the consequences of domestication? How did life change? Let's move out of the late Archaic and into the early Woodland Period to analyze this. In the Woodland Period, agriculture was proving to be an important supplement to diets. You might be imagining people settling down, abandoning the old hunting and foraging pathways, and focusing on full-time farming. That's really not what's happening, though. While it's true that domesticates were becoming more and more important and were being cultivated on a greater scale, they still relied heavily on wild foods like their ancestors. There are debates about how much of the woodland diet was made up of crops. In truth, this would have varied considerably from place to place. Some people may have been chowing down on those crops, while others were consuming them much more sparingly. Some scholars have argued that these comprised small fractions of woodland diets. However, there's a very interesting line of evidence at a site that many of you may be familiar with, Mammoth and Salt Caves in Kentucky. These caves were important sources of minerals like Epsom salts that were mined by indigenous people, but they were also settings of rites of passage for men. In the 1960s, archaeology by Patty Jo Watson revealed large amounts of human coprolites, or ancient feces, that could be analyzed, and these showed that the people going into the caves for mining and initiation rites were consuming seeds from EAC crops. And this was a big deal at the time because it proved that people were growing these crops for consumption rather than material uses. Subsequent analyses have shown that these crops made up anywhere from 50 to 90% of woodland diets, so they were clearly important for many groups. Not only do we see an increase in seed consumption within the EAC corridor, but we also see the EAC beginning to spread outside the corridor. A good example is the Manus site on the Delaware River in northeastern Pennsylvania. In historical times, this was Lenape land, and it's likely that the Manus site was inhabited by their ancestors. Archaeological work at the site has found remains of sunflower, goosefoot, sumpweed, and squash dating back to the late Woodland Period. This isn't an isolated example either. EAC crops also appear in archaeological excavations in the Piedmont of North Carolina, and also as far west as eastern Oklahoma. These developments correspond with an explosion of new construction and ceremonial activity. This is when we see the Hopewell traditions sprout up in the Midwest. These are famous for their mounds, rich burials, and exotic trade networks that moved goods like mica and copper over great distances. There's a lot we could say about these traditions and sites, but that's for another episode. All you need to know for now is that the people building these extraordinary mounds and mound complexes were cultivating EAC crops. It might be tempting to credit these achievements to agriculture, But I should remind you that people in the Archaic were building impressive mounds for thousands of years without any domesticated crops. Rather than looking at construction and exchange, I think it's more productive to look at how land use and social networks changed. During the Woodland period, there was a noticeable increase in sedentism, and the EAC crops appear to have played a role in it. Mobility was down, and this represented the start of a big shift in lifestyle. People began producing pottery to store and cook food, something that would have been a hindrance to constant seasonal mobility in the past. The benefit was that pottery would have allowed people to boil water and cook seeds more easily than before. There's also evidence of people clearing more land to plant crops, and farming appears to have shifted from a community effort to a household one. Remember how I mentioned earlier that late archaic gardens were community efforts based on communal storage facilities? The Woodland period begins a trend of people moving away from communal storage to household storage. As the period went on, large communal storage began to be supplemented by household storage pits. This suggests that people began viewing certain garden plots and produce as their own property. After all, when you forage, you get an immediate return on your labor, but when you farm, you're really making an investment that is going to pay off later. So it makes sense that people were beginning to store seeds and food in their own homes rather than as a group. Speaking of the domestic angle, it's likely that household relationships shifted as well. We know from later ethno-historical accounts in the eastern woodlands that women were the primary farmers and pottery makers in historical communities, and many speculate that the EAC was largely a women-led project. That's not to suggest that the men were bystanders. They likely would have been engaged in hunting activities that would have kept animals and pests out of gardens, particularly deer. There is some tentative evidence for a gender division of labor in burials from the late Archaic and early Woodland periods. Female burials tend to be buried with fewer stone tools and more pottery, and female skeletons are more likely to show degenerative joint diseases, possibly from agricultural work. If this interpretation is true, the relationship between men and women probably changed as farming took on more importance. Gardens also likely took on powerful cultural significance too. The act of saving seeds and replanting them in a garden is a powerful act of continuity that links family members with their ancestors. Those seeds that you plant in your household garden are the seeds of your ancestors who showed you how to prepare, plant, tend the plants, and harvest them as you would do for your own children. People who are familiar with indigenous food sovereignty are probably hearing some familiar themes here. Thus, woodland gardens, old and new, became important places of communal memory that reinforced cultural and family identities. On the community scale, harvest time was probably an important time of year that likely had important feasts and ceremonies associated with it. Another important window into the behavior around these crops can be seen in caches. Caches are very common in North American archaeology, and they represent a collection of material or foodstuffs that were stored for later use. For example, caches of tools and tool-making materials are commonly found at archaeological sites. Caches can also have deep cultural significance, such as burial caches that are meant to be used by someone in the afterlife. During the Woodland period, caches of seed crops became very common. Some of the rock shelters we mentioned earlier, like Marble Bluff and Cloud Splitter, also have later woodland caches, and this is behavior that persists well into the Mississippian period. So, what exactly are these seed caches that archaeologists keep finding? On one hand, we could just chalk these up as stores of an abundant harvest. A local rock shelter does make a nice emergency stash. It's also possible that these seeds were set aside for future garden plots in new areas, and this idea plays nicely into discussions of the dispersal of EAC crops across and outside the EAC corridor. However, there may be more variety than we appreciate. Cheryl Clausen has noted that several rock shelters with seed caches also have other materials, such as textiles and cradle boards, and based on this, she's argued that some of these rock shelters may have served as retreats for women during menstruation and childbirth or other events, and that the seed caches represented a special diet for these women on retreat. It's a really neat idea. During the Woodland period, however, there's an extremely important shift in agriculture, because that's when maize arrives into the eastern woodlands. Exactly when maize arrived is a little contested. Tiny phytoliths from maize have been dated at a few sites as early as 300 BCE. Phytoliths are tiny microscopic mineral remains from plants. Assuming these dates are correct, it doesn't look like maize took off immediately, but it's agreed by scholars that it was definitely being cultivated on an archaeologically visible scale by 900 CE. That may seem weird, but I'll point out that there's actually a similar pattern in the American Southwest. Maize first shows up in the archaeological record in the Southwest around 2000 BCE, but it doesn't really take off as a major crop until about 1,000 years later. Maybe people needed time to warm up to it, or the maize needed time to acclimate to the more northern latitudes before it could become a reliable staple crop. Remember, maize originally comes from the tropics, and so it was a bit out of its depth here. Either way, in time, maize would transform eastern woodland agriculture, and along with beans and squash, become a staple crop. Keep in mind, though, that during the Woodland and early Mississippian periods, beans were not being cultivated with maize. Those only show up a lot later. So, what did this mean for the Eastern agricultural complex? The short answer is that a lot of these crops would eventually be phased out over time, but the long answer is, as always, more complicated. The woodland people didn't just give up their beloved crops that they had grown for generations. This was a slow transition that took centuries. Let's take a look at the most important site during the late Woodland and early Mississippian period, Cahokia. We've covered this metropolis in an earlier video, but in summary, Cahokia was originally a woodland settlement near the confluence of the Mississippi and Missouri rivers that transformed into a full-blown city around 1050 and left a huge cultural legacy across the eastern woodlands. Cahokia's growth is often credited in part to the rise of maize agriculture, but it'd be wrong to say that maize alone fueled its rise. Archaeology shows us that during the late woodland phases, the area was inhabited by small communities intensively growing EAC crops in the floodplains. Between 650 and 900 CE, those communities began to increase in size and population, and things began to change. Houses began to be built in new ways, and early mound construction appeared during this time as well. Pollen cores from the Horseshoe Lake north of Cahokia Mounds today show that during the late Woodland period, the area was being cleared of trees. When archaeologists look at botanical remains at late woodland sites in the area, there's very little maize to be found. Instead, the assemblage is dominated by EAC crops. After 900 CE, however, it's a different story. Maize becomes much more visible in the archaeology. However, it didn't displace those earlier crops overnight. Instead, it was integrated into an already well-honed agricultural system. Many excavations of trash and refuse pits at Cahokia show that EAC crops were still cultivated on a large scale, and even made up major portions of the diet. As an example, an excavation below Mound 51 at the site revealed huge amounts of food remains, likely from one or several feasting events. Analysis of the botanical remains shows that starchy and oily seed crops like maygrass, goosefoot, sunflower, sumpweed, and knotweed made up more than 45% of the assemblage, compared to the 26% of the assemblage made up of maize. For those curious about the rest of the assemblage, the rest is made up of fruit, squash, tobacco, and other wild seeds. To add some context, Mound 51's construction dates to between 1050 and 1100, Cahokia's boom period. This tells us that the EAC was more resilient than we often give it credit. These crops may have been useful options in times and places when maize growing conditions were not optimal, a way for the farmer to hedge their bets. It's not until Cahokia began its decline in the 13th century at the opening of the Middle Mississippian period that maize slowly started to take the leading role in the fields. This was still a gradual process, though. Later Mississippian towns and settlements were still cultivating EAC crops alongside maize. However, as the Mississippian period marched on, there are signs that maize assumed a primacy. Stable carbon isotopes show that maize was becoming a larger and larger part of the diet, and maize begins to show up in archaeology at much higher frequencies. I couldn't confirm this in any of my research despite my best efforts, so treat this as my own speculation, but I suspect that this may have had to do with the introduction of beans to grow with maize. Interestingly, this didn't come up north with maize originally, but only entered the agricultural scene after Cahokia. This may not sound like a big deal, but all the Three Sisters fans out there know that beans greatly enhance maize agriculture. Beans grow up the maize stalk like a trellis and help add nitrogen back into the soil and stabilize the maize. This would have likely made maize agriculture more sustainable and profitable. Throw in some squash, and you have a way to keep the roots of both plants shaded and the soil moist. I also want to mention that the Mississippian period is also when new varieties of squash from Mesoamerica began to appear in the archaeological record. And while they didn't replace local squash varieties, they did become widely grown. With maize, beans, and squash, Three Sisters agriculture would dominate Eastern North American cultures, and it's this regime that greeted Europeans when they arrived in Eastern North America. Now, you may be wondering when and how those EAC crops disappeared from the fields and gardens of the eastern woodlands. While we could argue that it never truly ended because domesticated sunflower and squash are still cultivated today, it's not the case for most of those crops. Now, I wasn't able to find a study on the EAC that detailed the exit of those crops from the archaeological record across the eastern US, but I was able to find a few studies of Caddoan agriculture, and the findings from there were very interesting. Just for some extra context, the Caddo were and still are an indigenous nation with deep roots in western Arkansas, Louisiana, eastern Oklahoma, and East Texas that go back to the Woodland Period. Despite being outside the EAC corridor, those crops arrived in Caddoan lands around 1000 BCE, give or take, and they became a part of Caddoan subsistence for the next 2500 years. Now, it's important to keep in mind that the Caddo are not representative of the entire eastern woodlands, and that the timing of these changes here is almost certainly different than other areas of the eastern woodlands, but I do think that it's instructive nonetheless. That said, maygrass stopped being cultivated among the Caddo around 950 to 1000 years ago. Erect knotweed and goosefoot cultivation disappeared about 800 years ago. Sumpweed sticks around until the late 17th century, and at least in the Caddo region, outlasted sunflower cultivation by about 100 years. During these later centuries, some of these crops were still appreciated. We can see this at the site of Coquendel Break in Arkansas, which dates from the mid 14th to 15th century. Several burials were excavated at the site, and these burials had food offerings that predictably included maize and beans, but also acorns, sumpweed, and sunflower. The fact that these sumpweed and sunflower seeds were deliberately chosen to accompany these individuals into the afterlife means that they still had substantial cultural currency. However, by the historical period, the Three Sisters were running the show. In the Caddo region, we can see that maize agriculture slowly displaced those seed crops like goosefoot, knotweed, maygrass, and little barley, although sumpweed and sunflower stuck around until just before the historical period. It tells us that this transformation was not sudden, but one that was very gradual and slow. People were probably hesitant to part ways with food that had sustained their ancestors for generations. But what about these plants today? As I mentioned at the start of the episode, sunflowers and squash have continued to be cultivated throughout the world. The sunflower in particular has had a very visible cultural impact, becoming the symbol of many associations, including the state flower of Kansas and the national flower of Ukraine. Sunflower seeds are still regularly consumed as a snack or processed into cooking oil. Squashes and gourds are a mainstay in grocery stores, farmers markets, and Thanksgiving tables all over the country. Unfortunately, fate has not been so kind to the other members of the complex. I know that I said earlier that most of those plants are considered weeds today, but the situation is actually a bit worse. A lot of those plants are actually in trouble. Erect knotweed, goosefoot, maygrass, and little barley are in decline due to habitat loss and competition from invasive plants. In many areas, knotweed has been largely replaced by Eurasian varieties of knotweed. Maygrass populations are being wrecked by herbicides and the elimination of field margins. In fact, a survey in 2016 found that many recorded populations of maygrass in the Mississippi, Arkansas, and Missouri River valleys have disappeared, but thankfully, it is still common in conserved sections of prairie. Goosefoot has similarly been battered by herbicides and is getting outcompeted by herbicide-resistant invasive species. Yikes. Thankfully, botanists have begun to give these plants a fresh look to see if they have any food potential. Goosefoot in particular looks promising because of its close relation to quinoa. As the climate and environment around us change, these could be potentially game changing food sources. These crops are sometimes described as lost crops, but a recent term that is gaining traction is sleeping crops. This emphasizes their presence as a potential but dormant food source, ready to be awakened by a renewed interest. In summary, the rise of the Eastern agricultural complex is really noteworthy for a few reasons. First off, it makes Eastern North America one of only a handful of sites of independent crop domestication, right up there with more famous locales like the Fertile Crescent, Northern China, the Indus Valley, the Andean coast, and Mesoamerica. It's interesting that when we think of Native American agriculture in the eastern US, we tend to think of maize and the Three Sisters. And while that is an important development, it obscures a much more interesting story about the adoption of agriculture. Second, the EAC is unique because it doesn't seem to have arisen due to any kind of resource shortage or population strain. In the early 20th century, this was how the transition to agriculture was understood. It was seen as a sudden response to an environmental crisis, an agricultural revolution, if you will. With what we've learned about the Eastern agricultural complex, you can appreciate how this defies those models for how and why agriculture arose. It didn't replace archaic subsistence, rather, it was integrated into it. Although most of those crops are no longer cultivated, those plants are still here today, potentially ready for a resurgence. The next time you weed your garden, take a walk by a stream, or visit a prairie reserve, stop and take a look around at the plants and see if you can see any familiar faces from this episode. You might be surprised. And that's going to wrap us up for today. Special thanks to my patrons listed here. You guys are the best. If you would like to join the ranks of these fine individuals and support the show, you can do so on Patreon. The link will be in the description. Don't forget to subscribe, like the video, and follow us on Facebook. Take care, and we'll see you in our next episode.